Hi, everyone, and thank you for joining us today. If you're looking for the electrical safety webinar, you're in the right place. Just want to allow a little bit more time as folks file in. So we'll be getting things going in a little less than 1 minute. Again, we welcome everyone to today's webinar. I want to let you know that you are in the right place, just allowing a little time as everyone files in and gets settled in. So we'll be getting things going in about 30 seconds. Well, hello, everyone, and welcome to today's Safety and Health webcast, Implementing Continuous Improvement in Electrical Safety Against Electrical Shock and Arc Flash, sponsored by eHazard. My name is Kevin Drewley. I'm an associate editor with Safety and Health magazine, and we'll be moderating today's session. Thanks for joining us. We hope you all are safe and well. In a few minutes, we'll start the presentation, but first I want to go over some preliminary items. The views of today's speakers and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or magazine endorses those items. At the end of today's webcast, we'll conduct a question and answer session. To ask a question, simply click the Q&A button at the bottom of your screen, type your question, and click the send button. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speakers. At the end of the webcast, you'll be asked to complete a brief evaluation survey that will appear on a separate screen. We'll let you know more about that after the presentation. This webcast is archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. You may also receive a link in a post-event email. With that, let's go ahead and get started. Our speakers today are Zahir Juma and Hugh Hoagland. Zahir is a partner at eHazard who presents arc flash safety training, performs arc flash engineering studies, and serves as a subject matter expert on incident investigations. He has a master's degree in electrical engineering and is a certified professional engineer. Hugh is a service line manager for Arcware and founder of eHazard. An expert on electrical arc testing, he has helped write standards for ASTM, NFPA, and IEC ISO to protect against electric arc testing and electrical safety. Zahir and Hugh, we thank you for being here today. Zahir, whenever you're ready, go ahead and take it away.
Thank you, Kevin. Over the years, we've been looking at accidents and incidents that occur around electricity. And there was one thing that we found in common. Many of these companies have already have systems in place. And one thinks about this and wonders, well, if you have all of these systems, why are these accidents occurring? And that leads us to this discussion on continuous improvement. It is because we are kind of driven, and I'm not saying all of us do this, but what we notice is many organizations are compliance driven. And this fact was brought up recently by one of the leading thought person who has been leading thought and innovation on electrical safety, a gentleman by the name of Lanny Floyd, who mentioned this point again recently. And what he said is, do you know, we're after these check boxes, and once we get these check boxes out, we kind of smile and move on. But really, when it comes to electrical safety, if you look at the legislation, if you look at the standards that we follow, all of them warrant continuous improvement. So Hugh Hoagland and I just thought about, hey, you know, why don't we talk a little bit about this? So today's presentation, what we want to do is cover the basics of electrical safety. What are these electrical hazards? Then I want to put forth a suggested program implementation, which is 6 points that we'll cover very, very quickly. And then I want to spend quite a bit of time on continuous improvement. When I say quite a bit of time, that's the time within my portion. Before I hand over to Hugh to discuss the personal protective equipment and continuous improvement from a PPE perspective, and then we'll end off with a Q&A session. So As many of you know, electrical safety is regulated by OSHA, and they have minimum requirements. And these are covered both under the general duty clause and under specific duty clauses. And OSHA links very closely to NFPA 70E, although they do not issue citations exclusively based on NFPA 70E. What they do is they use 70E articles as references to support their citations generally under the general duty clause. So when we have shock hazards basically means current through the body. And what you have to understand is that this current is not only caused by contact, but very importantly, is also caused by approach to exposed energized conductors and circuit parts. All right. When we talk about lower voltage, single phase, 120 volts, we're looking at contact. All right. Then the approach kind of falls away. But once you step above those voltages, once you're looking at 208 volts, 240 volts, and multi-phase voltages, three-phase voltages, for example, in those instances at low voltage, when you get to within 1 foot, 12 inches of an exposed energized conductor or circuit path, you are exposed to a shock hazard. And then you have another hazard called the arc flash hazard. And those are the only two hazards that we need to be concerned about around electricity. It's shock and it's arc flash. Right. And when we talk about arc flash, it is something that occurs when a piece of equipment fails and releases energy. So the question then is, to understand this arc flash hazard, is exactly when are we exposed to this hazard, or when is this hazard present? Well, what NFPA 70E states is that the likelihood of an arc flash incident increases with exposed energized conductors and circuit parts, which basically means when you have a shock hazard, you will have an arc flash hazard. All right. The magnitude of the arc flash hazard can be substantial, or it can be marginal, or it could be one that cannot cause any harm. And the other instance in which an arc flash hazard exists is when we are interacting with equipment. So this is switching, testing, opening and closing doors and covers. Now, the reason I included switching in here specifically is because one of the big risks that we see out in industry at the moment is that machine operators and plant operators who are not considered electrically qualified, people who have not received electrical training previously, are expected to switch on and switch off electrical equipment. And many consultants and many industry experts will tell you that some of these machines have the ability or have sufficient arc flash incident energy to ignite non-arc rated clothing. So that's one of the areas that requires a little bit of focus, and just to make sure that there's nothing slipping under the cracks here. And what NFPA 70E also states, and this is very interesting, is that an arc flash hazard or an arc flash incident is unlikely to occur when equipment is used in its normal operating condition. And the big three that folks talk about is it properly installed, properly maintained, and no evidence of impending failure. So I'll talk about proper maintenance in a short while, but remember the gatekeepers of this is the arc flash energy needs to be greater than 1.2 calories per square centimeter to be able to ignite general, like civilian type clothing, and the worker needs to be inside an arc flash boundary for this hazard to be present. Okay, once you get outside of the arc flash boundary, that means that the energy has dropped substantially and will probably not ignite non-arc rated clothing. Now, what I thought was just putting out a picture and a video here to explain what I'm talking about. If you see a sticker on a piece of equipment that says the energy is greater than 1.2 calories per square centimeter, you are going to require arc-rated clothing, all right? And that means from head to toe protection. Just giving somebody arc-rated clothing and not expecting them to use any hand protection or head protection is not going to cut it. Hugh Hoagland's going to speak about this in a little while. And then here's a brand new video that we've just worked on recently, compliments of Arcwear and Kinetrics. Hugh can speak about this a little bit more. But what we see here is you've got two workers, and this is indicative of what we see in many, many industry. You will have an electrically qualified person performing a task, performing specific work, and then you'd have another person kind of observing this work, or somebody who's curious that comes over and asks the question, hey, buddy, what are you busy with? Right? And in this instance, what we saw was the mannequin who was completely protected from head to toe that's performing the work. didn't receive any burns, second or third degree burns, whereas the observer who's using normal uniforms that's not arc rated had clothing ignition. And folks, clothing ignition is the killer. As soon as we get away from the ignition of non-arc rated clothing, we are going to start saving a lot of lives from arc flash incidents. Right, so let's jump over to a discussion now on the electrical safety program implementation. The reason I want to talk about this implementation is because we cannot get to continuous improvement before we first cover the basics. And this is a recommendation on a 6-step process that we think needs to be in place before you can even start talking about continuous improvement. You know, you got to be brilliant at basics, get the basics in place. So it first starts off with training, create the awareness. You all will get a copy of this presentation, so I'm not going to get into the details and read through all of this, but I've included the details here for any one of you who want to circle back and make sure that you don't miss anything. What you want to cover in your training is the arc flash hazards, the control of hazardous energy, emergency response. And folks, as I always mention in my webinars, remember 1910.147 specifically excludes electrical work, all right? They have references that cover general commercial industrial installations, and they have another reference for generation, transmission, and distribution. So please make sure that you are not using your 1910.147 as an exclusive reference for the control of hazardous energy with regards to electricity. Emergency response, obviously very important. Care and maintenance of PPE, electrical equipment. Hugh will speak about this in a short while. And one of the big parts that he's going to cover is the personal protective equipment. And here's what I want to get across, the message, all right? Hands down, arc-rated clothing will beat daily workwear any day. Here, what you see is a mannequin exposed to an arc flash using normal street clothing, or even if it's not street clothing, even if it is industrial type of clothing, but it's not arc rated, what you see is clothing ignition. And once you have clothing ignition, it can get bad or it can get very bad. And Hugh's going to talk about a fantastic test that he did with 3 mannequins side by side, where he'll talk about ignition versus melting and dripping, because you can get bad and then you can get very bad. All right. So when we talk about protection, our recommendation is going to be try to address at least 80% of your hazards by providing arc-rated daily workwear. And the next section is going to go into this a little bit more in detail, but please circle back and have a look at these requirements, because what we see in industry is people use an arc-rated shirt and pants, but 9 out of 10 times they are not using the head protection correctly. So it is important that we have a discussion about the safety eyeglasses, the hearing protection, the balaclava, the EH-rated hard hat, the face shield. All of those are required. So you need head to toe protection as soon as you step into the arc flash boundary. And remember, the arc flash boundary can only exist when the arc flash hazard exists. So you got to do a determination as the employer on, is there an arc flash hazard present? Yes or no. And then you've got to be able to train your workforce. And OSHA is very specific about this. You've got to train your workforce to be able to identify these hazards by themselves. Step 3 is the arc flash engineering study, because in step 2, what we said is, hey, you know, just roll out arc rated clothing. And if you go between 8 to 12 calories per square centimeter, you are going to be addressing most of your hazards. The problem is you're not going to be addressing every single hazard. And to be able to get to that next level of excellence, you're going to need an arc flash engineering study. What is an arc flash engineering study? Basically, what this means is it's an engineering study that models all the electrical equipment, all the 3-phase electrical equipment that you've got in your plant. But in addition to identifying your incident energy, which it does via labels, it has the benefits of identifying protection settings, which is sometimes you would notice that you have a small little failure at some random location in your plant, and it trips up the main circuit breaker, and then you lose power to the entire plant. So problems like that can be identified as an added benefit when an engineering study is done. But the most important part of the arc flash engineering study is it tells us for each piece of equipment what the incident energy is. This means we can determine what is our maximum energy and what is the maximum energy that we wish to protect against. Because folks, remember, not every equipment is going to be aligned to commercially available protection. Let me give you an example. There's studies that have been performed where on a main circuit breaker, for example, the arc flash energy is 170 calories per square centimeter. Folks, comfortable arc-rated daily workwear, you're probably looking 75 calories per square centimeter. That's the arc-rated flash suits that's available. You can go up to 100 calories. Now you're starting to become a little bit cumbersome, a little bit heavy. So remember, you got to determine what is the maximum energy you have and what is the maximum energy you wish to protect workers against. And then when we talk about the labels, the minimum requirements for labels is going to be, you need to stipulate the voltage, you need to stipulate either the incident energy or mention to the worker what type of clothing they require. And then the third mandatory requirement is going to be the arc flash protection boundary. However, for these labels to be useful, we suggest that you provide a little more information. That means come up with some sort of a system where you discuss levels of PPE, talk about what is the equipment name, where is it fed from, what was the date that the label was applied. And folks, all of these can be customized. The label can be something that you can specify, but don't specify this in isolation. Talk to industry experts, talk to consultants, talk to folks who have rolled out these programs and ask them, hey, what worked, what didn't work, right? And your labels are, as I mentioned previously, your labels are going to tell you whether the daily workwear that you procured, the 8 to 12 calorie per square centimeter daily uniform, whether that is adequate or whether you're going to need flash suits as well. Now, in that gap between what is the maximum calculated incident energy from any piece of equipment versus the maximum PPE that you wish to provide, in that range where your PPE that you have on site is inadequate for the incident energy available from that piece of equipment, then you will not stick a orange warning label, but instead you will use a red danger label. And folks, these are regulated by ANSI Z535. And it basically speaks about when do you use a warning label and when do you use a danger label. So it has been observed in industry, because folks think, hey, arc flash is so dangerous that it's going to kill everybody. Folks have gone out and stuck danger labels on every piece of equipment. They've even put out danger labels stating that the energy is less than 1.2 calories per square centimeter. And when you ask them, hey, so folks, why did you do that? And they say, oh, because of the shock hazard. Well, if you can protect against the shock hazard, and there has been training, there has been a safety management system in place, there is adequate PPE, then folks, that is a hazard that can be protected, which means that it's a warning label, not a danger label. So please go back and have a look at the systems, because some of these may predate your arrival onto site. And I just want you to be aware of, use the right form of communication with your labels as well. Now, we've been talking about, hey, even if you don't know what the energy is, roll out 8 to 12 calories per square centimeter. But what I want to mention to you as well is that this clothing does have limitations. So here what we did was we put a mannequin in a flash suit and we put a mannequin in category 2 type of clothing, 8 to 12 calories per square centimeter. And we hit both of these with the arc flash, and the mannequin that had the flash suit on received no burns, while the one with daily workwear received 2nd and 3rd degree burns. Now, although you don't have the ignition of arc-rated clothing, you still have incident energy transmission from the equipment through the body of the worker. And that's where you see these incidents. So be careful about the limitations of daily workwear and the need for flash suits in certain instances. Now, once you've hit the first 3 steps, which was training, the rollout of PPE, the arc flash engineering study, step 4 is going to be the written electrical safety program. And folks, this is critical. It's going to cover your communication of all the OSHA regulations to your workforce. Step 5 is going to be your maintenance program. Folks, you can have the best safety management systems. You can have the most beautiful arc flash labels on your piece of equipment. You can have the newest, greatest piece of equipment. But if you have not maintained it, and if that main circuit breaker cannot trip and clear the arc flash energy or clear and protect the worker against electrical shock, all of those safety management systems are going to fall on their face. So because of that, maintenance needs to take a forefront in electrical safety. one of the most basic and rudimentary forms of maintenance is going to be a thermal scan. Even folks, even if you don't do anything else at the moment, just start off with a thermal scan. A thermal scan is going to be able to identify existing problems as well as developing problems at low voltage. Once you get into high voltage, there's going to be a whole lot more that you can do. But for low voltage, the very basic you can do is an infrared or infrared thermography, infrared scan, as they are called. Now, I've also put out a slide here where I've discussed what can you do with transformers, circuit breakers, panel boards, and some of the general requirements. Have a read through that in your own time. And auditing, all right, step 6. This is the final step that I'm going to be talking about in the program implementation. What most of the consensus standards speak about is you want to hit 3 different areas. You want to hit your safety management systems in terms of an audit. You want to check the worker, inspect the worker, and you also want to inspect the tasks. All right, so those are the big 3. What is your documentations looking like? What are your documentations looking like? What is your worker looking like? And what are the tasks looking like? All right, and remember, there's document retention requirements for these as well. So you cannot just go out and do a verbal inspection and say, hey, I'm done. No, you need to have a documented program with findings allocated to the right person, due dates, commitments, right? And that's where you start adding value. So just to summarize these 6 steps: training, procurement of daily workwear, the arc flash engineering study, written electrical safety program, the maintenance program, and then the auditing program. So with that, we're going to jump very quickly into continuous improvement. And folks, if you really want some good references, if you really want to take this continuous improvement ideology and implement it, I've provided you with 2 excellent resources that have developed over time, and it makes great reading. And one of those papers actually tell us they provide 3 different examples on continuous improvement and the various steps. And I've circled example number 3 from one of these papers because that's going to be our focus today. So the basics of continuous improvement stems from quality control. And for those of you who have not read this, I'm not going to get into super duper detail. I'm going to hand over to Hugh in the next 5 minutes or so. So just very quickly, it's called the Plan, Do, Check, Act. And we've evolved that to try and make it electricity focused. So we've created our own wording with regards to this, but I would really strongly suggest that for those of you who are interested in quality control, have a look at one of the Ishikawa books. And this was translated by David Liu back in 1985. Very interesting book that goes through all of the details. So how do we make this electrically centered? All right. How do we take the Plan, Do, Check, Act and implement it with regards to electrical safety? Well, the basis of that lies in NFPA 70E articles 110.5 and 110.6. All right. And there's these core elements that we speak of the electrical safety program: performing the risk assessment, training, accident investigations and incident investigations, audits, and maintenance. So let's run through each one of these, right, very quickly. What's the 4-step process, the Plan, Do, Check, Act on your electrical safety program? One of the first things is, please do not do this by yourself. This is not a one-person band. This is not something that you do in an island. Get together a multidisciplinary team, all right? Once you get a multidisciplinary team, you're going to get different ways of looking at things, different ways of doing things, and you're going to get a procedure, a written document that's going to apply to everybody. Train your workforce, roll out the program, and then do your 3-year program audits. Perform annual supervisory inspection, look at incident investigations, and then that's going to get you to the question in terms of evaluating your program: are there gaps in my program? And once you find those gaps, use standards, use references, use white papers, attend conferences, and find out, hey, how can we plug this gap? When it comes to training, sure, you can develop your training in-house. Absolutely, you can develop your training in-house. But how do you know what you don't know? All right. And this is why at least at the beginning, look what other companies have done. What have similar organizations done? Attend conferences, learn about what are the different questions that workers have, that safety managers have, that production managers have, right? Look at all of those and come up with an idea on how are we rolling out our program, and then develop your training and then launch your training. But once you launch your training, go back a year later and ask the folks, hey, do you remember this? Can you explain this to me? Or have a look at what are your audits telling you? And then based on that, make the changes to your training program and update, change, periodically. NFPA 70E standard changes once every 3 years. Make sure that you keep up to those changes as well. When we talk about audits, very interesting, audits also need to be continuously improved. Folks, you can ask the same question every single year and get the same answer every single year. Come up with new creative ways to ask these questions. And we provide some guidelines here. You can read through that on your own. Maintenance, I just want to speak about this very, very quickly. Have a program for high voltage equipment and low voltage equipment. Prioritize your equipment based on age. Establish these KPIs in terms of, yes, I do have high voltage equipment, but if this equipment fails, it's not going to affect production. But you may have a very cheap piece of equipment that's in the core main line of production, where if that fails, hey, that's going to make our entire process stand. So come up with some sort of a scoring KPI where you can prioritize your equipment, all right? Then there's multiple resources available. You can go online, you can speak to your equipment manufacturer, you can speak to subject matter experts and ask them, hey, what is the cheapest, nastiest thing that I can do right now? Something that I can start today that's not going to cost me an arm and a leg. Then you say, well, what's going to cost me a little bit more? Okay, let's budget for that next year. Then what you do is look at KPIs in terms of what is my mean time to repair? What is my mean time between failures? Come up with those sort of KPIs and then look at your program. What have we been measuring 10 years ago versus what are we measuring today? And from there, improve your system. And with that, I'm going to hand over to Hugh. And Hugh, I'm just going to try and pass control off to you. And you should have the mouse right now.
All right, I think I do. In terms of PPE, I'm not going to go into a ton of detail, but I'm going to give you some opportunities that we've seen in improving programs. And Zahir, I don't think I've got the control yet. There it goes. Okay. So we'll talk about continuous improvement in the area of selection, care, and use. Going to hit all three of those. The one big thing is in selection, making sure you're thinking about multiple hazards when you're looking at your PPE. A lot of arc flash PPE is great for most applications, but some applications it's not as good for. Chemical is one example. There are suits that are good to put over top of a regular arc flash gear. There are fibers that work better in chemical exposures, not just for protection, but also primarily in holding up against acids or bases or things like that. And so looking at your system, looking at steam, looking at weather, winter wear, we've had people that just throw out arc flash suits and think they're perfectly warm. Well, they're not really designed to be warm. They're designed to be thermally insulated from an arc flash, but sometimes even though they're very thick, they're not really warm. So looking at winter wear that's arc rated and then using a flash suit hood with that. There's lots of different ways to do that. And then also fall protection. We see that some people don't address. Utilities typically do this very well, but there are arc tested fall protection devices, and that's really important to make sure you're looking at your whole program. When we do audits, and I've recently retired, but when I did audits, I would always look at the PPE to make sure that it was correct. And then I would talk to the people and find out, do you wear this? Do you like this? Are there issues? And then try to dig into what those issues are and try to make it. Comfort improvements are always important. Comfort rocks. People love things that are comfortable, and you want them to forget about PPE. You don't want them messing with PPE. You don't want them hating PPE. You want them just to think about it as, hey, this is what I wear when I'm at work. Winter options, using winter wear as a flash suit, which I mentioned earlier, and then also using rainwear as a flash suit, which is my very first paper was my utility. We arc rated rainwear materials that were really new at that time back in 1997. and we used them as a flash suit. We just put this arc rated wing wear on every truck and used it as a flash suit over top of our daily wear. In the summer, look at wicking underwear. Look at higher air permeability shirts. There's some that are very low air perm, some are very high air perm, and they make a big difference, especially if you have good wicking underwear underneath to make your workers more comfortable. And also, you can take advantage of those layers by getting the layered ratings, and more companies have those now. Also, using cooling technologies, especially when you're wearing a flash suit. There are tornado type cooling devices that you can wear that using compressed air, they force that up to the worker, and you can also use those, you can use other type of cooling tech. There's lots of them out there that are arc rated or arc tested at least. And then using fans in your arc flash suit hoods. It makes such a huge difference using a fan. And that's one of those things that's a quick and easy upgrade. Next time you buy new suits, make sure you go ahead and buy them with fans. They really make a big difference in wearing them. Stay abreast of the standards in your selection. There's 2 new standards that have come out. We've had presentations on recently, but not with Safety and Health magazine. There is a cloth face covering standard that does allow for arc ratings. And then there's also a arc rated protector glove standard that doesn't have to be leather. All protector gloves had to be leather up until this standard was released. And because OSHA requires protector gloves, but doesn't require them to be leather, this standard would be perfect to be able to implement in your program. And we'll talk a little more detail on that one. Then also IEC, if you're an international company, there's IEC glove standards that I'm the project team manager for and writing right now, working with both the end users and the manufacturers and the test labs to make sure we have these similar gloves would be available with IEC labels. And then FR respirator standard, there's some respirator standard that's working right now in forget which group in ASTM, but it is for firefighters, but those should help to make opportunities out there. There's lots of research now being done on that because of people needing to wear respirators and also having arc flash hazards. And then we're recently working on updating the arc blast blanket standard, which is a very useful standard if you have applications where you want to shunt arc blast away from workers that may or may not be properly protected. So an important standard to use. I always recommend to use ANSI ISEA 203 and get an arc rating on that fabric. The fabrics are flash fire tested as part of 203. They have flame tests. They have all kinds of details in them, but get them with an arc rating, and they're excellent to use over top of gear if you have some minor chemical exposures. So just make sure you think about that and use those. This is the 3258 standard. What it's doing is it's going to allow thinner and lighter weight over gloves that you wear over top of your rubber insulating gloves. It'll allow for more dexterity, but also for more grip because they can, like this one, have grip coatings. And they're also can be more cut resistant. They allow you to test for cut testing. Before the ASTM F696 standard, all it does is it's a leather of a certain thickness as you go up in class of gloves. But now they don't have to have any leather, or like in this case, they can have leather, but they can have other materials. Like this one, I think is lined with Kevlar in one of the options so that you can get better cut resistance. And so this is a brand new standard just off the presses with ASTM. And also it is now being added to the NFPA 70E 2024 version as one of the options. And in NFPA 70E, they don't require you to use a specific standard, but they do require you to have arc rated gloves at certain levels. And so this would already meet 70E, but it will actually be mentioned in the next version of 70E. At least it is in the first edition that's out now. And when we test gloves with the regular leather gloves, they don't have to have a flame resistant cuff. And so in this video, you'll actually see 3 out of these 4 gloves did have a non-FR cuff. One of them had some flame resistant treatment and does put itself out. The other one is an all leather cuff. With the new 3258 standard, none of these gloves except the leather one and the one that put itself out would be allowed. And so you don't know what you got with the 696 standard because there were some things that were left out of that standard back when it was written back in the 70s. And it really hasn't been upgraded much since that time. I'll go on to the next one. Even daily wear can save lives. If you saw, and this is just one of the things, if you're looking at a continuous improvement thing, putting your electricians in daily wear that's arc rated all day long. There's so many companies that just buy kits and they throw the kits on people. I think the kits are great. It's quick and easy to carry around, but just have an arc rated daily wear. I've been on many accident investigations now, over 225. And what I found in those accident investigations, the people who die or get really, really badly burned are wearing non-FR gear and they're near or in the arc flash. Most electricians now know that, okay, at certain points when I'm making it safe, when I'm de-energizing, grounding, testing, I need to wear arc-rated gear. But there are a lot of accidents where people or even supervisors that are supervising, but are not officially doing the work, but are really nearby, like that example Zahir showed you earlier. Our recent video was part of a process we did for a clothing company, but it also replicates an accident, 2 different accidents I've seen, where the building service manager was there with an electrical consultant or electrician that they had hired to come on site. It's a contractor, and the supervisor in one case and the owner, or well, the building manager in the other case, their clothing ignited and badly burned. And one person died, the other person was just badly burned. I'm really for arc rated daily wear. This is an example of not wearing arc rated daily wear, and the suit just wasn't enough to protect it. And here's an example of wearing arc rated daily wear under that suit. So those underlayers do matter in some of the incidents. Right stuff really makes a difference. Cotton, polycotton, there is a slight difference in the survivability, but the survivability of arc rated materials, in this case an aramid, is dramatically different. Almost everybody I've investigated, even if they weren't matched to the hazard, even if they weren't wearing exactly the right PPE, they lived when they were wearing arc-rated materials. And about 50% of the time, you expect to have a person die if they're wearing non-arc-rated materials or be badly hurt. Probability of survival goes with this. Arc-rated exposure with arc-rated clothing, you're about 95% chance of living. Whereas if you have a shirt that catches on fire or a shirt and pant that catches on fire or a coverall that burns off of you, your chances of living go down dramatically and your quality of life changes quite dramatically after 25% body burn. And making sure that the winter wear that you're putting people out, if they're having to work outdoors or they're having to work in cold environments, making sure that winter wear actually protects the workers is really important. And one of these is arc rated, one of these is not. But obviously the one on the right is a little warmer in the winter, but not the way you want to be warm. One of the big improvements, looking at your PPE and asking, has PPE gotten better? And if people are having to wear PPE for 5 minutes, not a big deal. Probably doesn't matter that much at all, unless they're in a dark environment. But the new hoods that are coming out with the lift front designs, they help prevent fogging, they help be able to defog, they help people to be able to communicate better when they're in electrical working conditions, and they can pull it down when they get ready to do the arc gear. And it's amazing how well these work. We've done a lot of testing on these. There's a lot of other designs that are coming out now that are lift front type materials. But the biggest change is making these gray shields. My original patent on arc flash face shields, which I didn't make any money off of, but it's something I helped patent back in 1997. That original patent had to block a lot of the visible light spectra, and it blocked specifically blue and green so that you couldn't tell what color wires were. These new technologies are just fantastic because they've now got a shield that's up to 20 cals that looks perfectly clear. It is 100% light transmission, but it does block certain wavelengths, not only the infrared and the UV, but it blocks a certain amount of wavelength of light that's not enough that you can visually notice the difference. And up to 100 calories, they're a lot clearer now, and they don't have to be the old green shields. So switching that out is an improvement, and it's a continuous improvement, because what this does is it gets you a newer shield, but it also gets you the ability to see the colors, the ability to not need so much extra light. People will take off shields, and I've had 2 accidents where that happened, where they took off their shield because they couldn't see and then got in the arc flash. So it's really important to make sure people are comfortable in their gear and they can wear that gear when they're doing the work. And then another thing we see is continuing to make sure that you upgrade your systems. Here we have some high visibility vests. One is arc rated, the other one is not. The one that's not arc rated just melts all over the worker. Making sure you're not just wearing the old FR, flame resistant, you're actually wearing something that has an arc rating or has a flash fire rating. That makes huge difference for the workers. And then here's the arc rated or the arc tested F887 standard, which is for fall protection, that is for electrical workers. And here's the proper kind, and then we'll also show you the one that's the improper kind. We've seen a couple of accidents with this. What I primarily see is people wearing the wrong kind and then it not working for them in terms of just burning them. I've never seen anyone fall from this, but it could happen, especially if they got in an arc and then jumped away. As it's burning, they could fall after the fact. And our utility had someone that jumped out of a bucket after an arc flash, and their gear was not arc tested back way before this was even available. And that's one of the reasons I helped develop this standard, the utility I used to work for. Care. We talked about selection. Now we're going to talk about care. Make sure you have proper cleaning. Professional laundry versus home laundry. If the contaminants are things that people should not be taking home to launder, you really are required by OSHA to do laundry service for that. Material choice. You may decide that you don't want home laundering because of that, or it may be because of your image your company wants to portray, or that you have workers that may not iron their clothing and you want them to look good. So it depends on your work application situation as to whether these matter to you, but you can choose either professional or home laundering safely as long as you do it right. And then do you repair it or do you replace it? Really depends on, can you get a company that will repair it for you? Many professional laundries will repair correctly, so that's really important. Make sure it fits. You don't want high waters with your arc flash suits. I literally have seen an accident where a person was very tall. He was given an arc flash suit that was a quote unquote one size fits all. His blue jeans were hanging out the bottom. The switch gear arced and it came out the bottom, ignited his blue jeans and burned up to his knee. So he got really bad burns. But if he was wearing the right size arc flash suit, that blue jean would have been okay. Or if he'd worn an arc rated undergarment, if his normal clothing was arc rated, he would have been okay. Would have had very limited, if any, burns at all. And then making sure if people are taking the arc rated hoods apart to launder the hood portion, either for sanitization or just for comfort or just for smell, then make sure they know how to put that back together. It's really important. I do know that some of the professional laundries are now offering that as a service of cleaning your arc flash suits. You don't have to pay for weekly laundry on those, but you launder as needed. A lot of companies are doing that and they know how to put them back together. It's really important to make sure you do that correctly. And then tuck, button, and roll is really important. We did this test for a utility. Their workers were sometimes not tucking in their shirts, and we showed that with half as much energy as we normally expect, we could ignite the cotton underneath. And it's hard to tell, we cut off the video too soon here with a new technician in this video, but these actually, the t-shirts ignited and burned off underneath the arc rated shirt. Roll those sleeves down, tuck the shirt in, and make sure you button it up as far as you can when you're doing work that has an arc rated potential. So that's kind of the main things in PPE that I see that people can improve. We do have a couple of questions, and we'll also take any more questions. If you haven't asked one, feel free to ask it right now in the question section. I'm gonna turn it back over to Kevin.
All right. Well, very well, guys. Appreciate it very much. Great insights and great expertise today. Before we do get to that Q&A, just want to remind everyone of the evaluation survey that we're asking you to complete. The survey will open in a different screen after this presentation. Your input is important because it'll help us improve future webcasts. And again, we appreciate you taking that extra time to offer feedback. As you mentioned, it is time for Q&A. And as a reminder, if you wish to ask a question, simply click the Q&A button at the bottom of your screen, type your question, and click the send button. And with that, we will dive in. First question asks, how often must these, how often must those labels be placed, and do they need to be dated?
Hugh, if it's okay with you, take a stab at that. Right. So I'm assuming here that the labels you're talking about is the arc flash label that goes on equipment rather than the labels that Hugh was talking about on PPE that tell you whether it's ASTM F1506 compliant or not. And the requirement for the study is that the study needs to be reviewed and updated at intervals not exceeding 5 years. Now, what we find from quite a few studies that we have done is that the majority of those labels remain unchanged. So the information on the label remain unchanged. And because of that, we strongly recommend avoiding the date on the label. Now, we're not saying that putting the date is wrong. If you want the date on, then by all means, go ahead and stick the date on that piece of label. The problem is I was out at a site not too long ago, probably about a month ago. And although the information on the label was valid, the label had a 2012 date on it. And so the electrician comes up to me and says to me, hey, our engineer stuck this label on and it says 2012. Can I trust that label? And I said to him, well, yes, I've run the numbers again and the values on those labels are still current. And so he looks at me and says, well, yeah, that's what you are telling me when you're not here. That's what you're telling me because you're here. What happens when you are not here? Can I still take that label at face value? And so it's a really difficult discussion on whether to add a date or not. The label itself doesn't have an expiration date unless you stick a date, on it. And if your program says that any labels installed more than 5 years ago are not valid any longer, then those labels will be invalid. If your safety program says that irrespective of the date on the label, every worker should follow the information on the label, well, then those labels will be acceptable as long as the information on that label is still correct. Hugh, is there anything you want to add to that?
No, that's perfect.
All right, our next question asks, regarding gloves, our employees continually ask about an all-in-one glove for arc flash and shock protection to further improve dexterity. Can you comment on what you're hearing about this in the industry, and would this even be possible?
Yeah, and unfortunately, there are composite gloves in the IEC standards, which would be allowable at least in every country except the United States. The problem with the composite gloves is they really don't have better dexterity, because when you have one glove, you always have to compromise something to get all those qualities. And so dexterity is not one of the things you gain. It's just not having to wear a protector glove. But that, again, is not allowed in the United States, but it is commonly done throughout the world other than the US. We recommend you look at those new protector gloves and focus on that. Using a low voltage glove, if you're doing low voltage work, and one of these newer protector gloves can probably increase your dexterity. And I think there'll be a lot more options coming out pretty soon. We're still working on that standard, and there are only a few that are out right now. But as you ask your glove manufacturers for those types of things, they'll look into developing. It's the way it usually works.
Next question asks, where can I find a list of activities where there is arc potential? For example, changing a fuse.
I'll let Zahir take that because it's right in 70E.
Right. So NFPA 70E speaks about the principles where they identify the hazards. However, one of their requirements is that the employer is responsible. And this is echoed under the general duty clause and the specific duty clause. Have a look at 1910.335. 1910.335, which goes over the specific requirements. And now I understand that OSHA is a little bit vague in their requirement, but basically what it says is that the employer shall actually look at all of the equipment that they've got installed using the principles conveyed in what is an arc flash hazard, what is a shock hazard, basically go through this. Now, changing a fuse is a very common one. We've just completed an accident investigation where a worker was replacing a fuse on a bus duct. Folks, these are those installations high up in the ceiling on the roof, and you have a plug that drops down from it. And what happened was this worker got onto a lift got up to this fuse, tried to pull out this fuse using the correct tools, but when pushing this fuse back in, because of the clearances of that type of equipment, there was an arc flash accident that occurred. So yes, the way we look at it is once you're replacing a fuse, depending on the size of the fuse, some of these are going to be mechanically intensive. That means you've got to really, for lack of a better word, manhandle those fuses to be able to get them out and to get them replaced as well. Now, think about it. If your line side, the incoming side of the power is still energized, could an arc flash occur? And this is considered a high risk. So there are tables in the NFPA 70E. There's a table 130.5C that provides great details on when an arc flash is likely to occur and when it's unlikely to occur. My recommendation is have a look at those tables. Have a look at those tables. Even table 130.7C15 covers a little bit more. Have a look at those two tables in NFPA 70E. We've got a picture here of the standard, the latest standard. So go ahead. I would strongly recommend that every company buys a copy of the standard and keeps it with them.
When you're cleaning rated PPE at home, does a certain detergent have to be used?
Hugh, are you muted? I think we've lost Hugh.
No,
right.
you haven't lost me. Sorry, I was muted and I was already answering. I apologize. We've done a pretty extensive study using Tide brand. I'm not recommending Tide brand specifically, but buy your detergent locally and use powdered detergents because they don't have to compromise to keep everything in suspension. So you use a powdered detergent, buy it locally because usually they're formulated, especially the better brands, are formulated for the hardness of the water in your area. And so use that. Also, be very careful, check with the manufacturer and see if they recommend anything, other specifics like degreasing or anything like that. We don't recommend that you use chlorine bleaches at all. Some fabrics don't have a problem with chlorine bleaches. You can usually use a peroxide bleach for home formulation, but they can be dangerous if you're using them at an industrial level because the amount of peroxide is higher. But small amounts of peroxide bleach we've used in a wash study with some of the most vulnerable types of fibers. And what we found is at 250 washes, they were still almost as good as they were when they were new. No wears, just washes and dries. So it worked quite well. And those are published, I believe, in ASSE's Professional Safety magazine.
Next question is kind of looking for some feedback about convincing an organization to adopt a 70E program. They state that they often find resistance to spending money to hire engineers for assessment and gear. So they thank you for the training, but seeing what feedback you might have in that area.
Yeah, Hugh, maybe I can just take this first and then you can supplement my answer. One of the references that I've linked to has a great paragraph. It's slightly dated, but they talk about the cost to implement a program versus the cost if a program was not implemented and there was either damage to equipment or injury to a worker. And those values were absolutely ridiculously crazy in terms of how much a company can lose. We're talking about hundreds of millions of dollars compared to about, it worked out to about 3% of the total cost of your program versus if an accident were to occur. The other thing that I would strongly suggest is attend local conferences, attend webinars, attend anything that says electrical safety. And there's a ton of information that's shared with regard to, hey, we've had this accident, here's how much it's cost, here's the suffering, here's a lack of trust in the company, et cetera, et cetera. The other problem is when it comes to electricity, safety is important because safety is going to keep your production running. As soon as you have a safety accident, especially if it's an arc flash accident, you are going to bring production to a standstill. Hugh, do you want to add anything?
No, I think that's probably the most important thing. One accident pays for your program, studies, everything, but you're making your plant more reliable too. Because one of the things that happens in an arc flash study is you're doing also, or at least I'd recommend to add on a current study, looking at the current in the system and seeing if there's any equipment that needs to be upgraded or settings on your breakers that needed to be changed. They can lower the arc flash energy, but they can even make your equipment more reliable. That maintenance that here talked about is critical for arc flash, but it's also critical for keeping that company reliable. Not just being shut down for an OSHA problem, but being shut down for an electrical problem or blowing up switchgear that may take, without supply chain problems, blowing up a switchgear or transformer can take anywhere from months to 6 months to a year to replace. So making sure that you're taking care of that electrical equipment that runs everything in your plant is really important, and sell them on that idea too, because that's probably just as important and more likely to happen that the equipment blows up and nobody's standing there than it is that somebody's actually standing there. So really important to think about it from two perspectives, especially the engineering piece.
What is the requirement for 70E training for electricians?
70E requires that they be trained for safety. It doesn't say how long that has to take or anything of that nature, but it does require that they have to be trained. So it's really important to make sure that I recommend training at least every 3 years. That's one of the requirements in 70E. But you also look at, and he's gone back to this slide that gives you some more details in our electrical safety written programs, which that was one of our examples. We have all this spelled out. It really depends on how much you do. It's annually. If they're working with high voltages, that's an OSHA requirement that they be trained on anything they haven't done in the previous year. And in terms of normal training in 70E, it's every 3 years or every time the standard comes out. So just making sure that when the standard comes out, you retrain. And also, if you're auditing and you find out that there's a problem, then you may require an individual to be retrained, or you may find that that's a problem throughout your company and you may need some refresher training for that too. It can be on the job or classroom. We recommend a little bit of both, but those are the requirements in 70E and the requirements from OSHA.
This next one's in sort of a similar vein with reviewing some things. How often must arc flash PPE be inspected or certified?
There's no certification for arc flash PPE, but it's recommended that you inspect it before each use, making sure that it's not contaminated with anything that could be flammable, and then making sure that, there's no tears or rips, because you could get fire through those. It won't continue to burn. That's just the way those materials are, but making sure that it's in good working repair is required. I recommend that on arc flash suits, you change out at least every 5 to 10 years. And on the face shields, typically they recommend every 2 or 3 years. Same thing with the hard hat, depending on the manufacturer, anywhere from 1 to 5 years, you should change out the hard hat and face shield.
Are cloth face coverings FR rated, and are there any concerns with breathing in chemicals from the FR rating?
No, I don't think there's any hazards with any of the materials that we've looked at. Most of them are Okiatex certified, which is a European chemical certification for clothing. And the ones that are typically the ARC rated materials in the US are Okiatex certified for children's sleepwear. So, I mean, super, super low amount of chemicals coming off of them. So I've never known anything. We know some people that are allergic to materials, but typically it's the dyes, not the fabrics themselves. And also, usually if you find somebody who's allergic to something like that, it's just because they're getting too much moisture and they're getting a heat rash, or sometimes people are allergic to what they're washing it in. So be really careful what you're washing it in, and make sure you rinse out all the detergents and things of that nature.
Next question is asking, just says appreciates all the resources that were shared today, but they say they're a new safety professional and want to continue learning about electrical safety and seeing what additional resources you might have.
Well, he has training, but also I would always recommend you attend the electrical safety workshop. It's an IEEE conference, and it kind of keeps you up to date on all the newest stuff. But eHazard has tons of training that you can do. Many of the classes are online, and you can learn a lot that way. And they also offer a train the trainer. I don't work for either company anymore. I'm retired, but an excellent company that I used to be a part owner of.
Yeah, and Hugh, I just want to add, all of the work that Hugh and I, together with a few industry experts, have done with regards to continuous improvement is included in that link just above the Aqua and eHazard's name, the learning and safety cycle. There's a ton of information there. All of that is in the public domain. It's readily available. And if you have the standard and if you follow those guidelines, you should be in a good position to continuously improve your learning. All right. Thanks.
You both have been quite thorough today. As we wind down, anything left unsaid or any closing thoughts?
Just make sure if you'd like a PDF of this that you write to questions@e-hazard.com. Brian McCauley will send you out a PDF. It'll be available probably tomorrow. I think Zahir will have that created, and you'll get a PDF of all the slides.
All right. Well, no, again, thank you. Unfortunately, we have run out of time today. Sorry that we didn't get to everyone's questions, but all of today's unanswered questions will be forwarded on to our speakers. And once again, we hope that you take that time to fill out the evaluation survey and provide your feedback. With that, we end today's Safety and Health Magazine webcast. We'd like to thank Zahir Juma, Hugh Hoagland, everyone at eHazard, and all of you who listened in. Thanks and have a great day.